In today's video, I am going to teach you about maps in Kotlin. Hello and welcome to Learn with Tam. I'm Tarique Ali Mirza and my goal is to make you a kickass Android developer. If you are new here, I suggest that you watch this series from the beginning to get the most out of it. Up until now, I have taught you about lists and sets. In today's video, I will teach you about maps, a collection of key value pairs in Kotlin. Since you are already familiar with lists and sets, this lecture is going to be very brief. So, without further ado, let's jump right into the system and get started. As always, open Android Studio. Now click on Create New Project. Select No Activity, then click on Next. Give the project a name. Then click on Finish. Once your project is ready, go to your Project Explorer and open the App folder. Then open the Java folder. And then right-click on the Package folder. Then select New. Then select Kotlin file. Now make sure to select File from this list. And then give a name to your file. And press Enter. Now create the entry point function. Maps is a special collection in Kotlin which is used to store logically related information as key value pairs. Each key in a map is unique and is associated with exactly one value within the map. Let me show you an example. In this example, the numbers 1 through 3 are keys and the string tam, sam and zam are values associated with those keys. It is not necessary for the keys or values to be of a specific type. They can be of any type. Let me show another example. In this example, the strings tam, sam and zam are keys, whereas the numbers 1, 2 and 3 are values associated with those keys. In the previous example, our keys were numbers, whereas the values associated with those keys were strings. In this example, the keys are strings, whereas the values associated with those keys are numbers. Let me now print both the maps. And now, let's run the program. As is visible in the printed output, the first map has the keys 1, 2 and 3, and their values are tam, sam and zam, whereas the second map has the keys tam, sam and zam and their values are 1, 2 and 3. The keys and values are not limited to strings and numbers. You can have any type of data as your key as well as your value. If for some reason your program requires you to access the set of keys or the collection of values within your map, then you can do it using the property keys or the property values. Let me show you how that works. On line number 10, I am using the property keys to access the set of all keys within the map, whereas on line number 11, I am using the property values to access the collection of all values within the map. Let me run this program so that you can see the output. As you can see, in the map variable, the keys are 1, 2 and 3, whereas the values are tam, sam and zam. Let me now also print the keys and values for another map. And now let's run the program. As you can see, for another map, the keys are tam, sam and zam, whereas the values are 1, 2 and 3. That was about accessing keys and values separately. But in case you want to access all the entries within the map, you can use the entries property as well. Let me show you how that works. On line number 16 and 17, I am accessing the entries of both the maps. Let me comment out the previous print statements and run this program. As expected, running this program printed the set of key value pairs for both the maps. Moving on, if a map has multiple identical keys, the value from the last occurrence of the key overwrites the previous ones. Let me show you an example. On line number 21, I have used the keys 1 and 2 twice in this map. The first occurrence of key 1 has the value nam, and the second occurrence has the value tam. And for the key 2, the first occurrence has the value sam, the second occurrence has the value ram. Let me now run this program so that you can see how this map is stored in the memory. As expected, the last occurrence of the key 1 had the value tam, and that's what we see here. And the last occurrence of the key 2 had the value ram, and that's what we see in the final output. Ideally, you should not have identical keys in a map, but if you end up having them, please remember that only the last occurrence of that key will be stored, and the rest of it will be rejected. Moving on. If you wish to get the value of a specific key within a map object, you can do it using the get method or the indexing operator. Let me show you how it's done. On line number 25, I am using the get method on my map object to get the value for the key 1. On line number 26, I am using the indexing operator to get the value stored with the key 2. Please note, the numbers 1 and 2 used in these examples are not the indexes, they are the keys. Also, on line number 26, the indexing operator is working as a shorthand for the get function. Let me show you another example to clarify this further. As you can see on line number 28, I am using the get method to get the value stored with the key tam in the map named another map. And on line number 29, I am using the indexing operator to get the value stored with the key zam in another map. Now let's run this program so that we can see the output. It says that the value stored with the key tam in another map is 1 and the value for key zam in another map is 3. As you can see, in another map, the value stored with the key tam is 1 and that is correct, and the value stored with the key zam is equal to 3 and that is also correct. Moving on, just like lists and sets, even maps are immutable by default. So, we cannot modify, add, or remove entries from them. Let me show you how to create a mutable map. On line number 33, instead of using the map of function, we are using the mutable map of function, which returns a mutable map. On line number 34, we are simply printing the mutable map. Let me run this program so that you can see the output. As expected, a map has been created with 3 entries of key value pairs. So now, we can add, remove, and modify the entries of this map. Let me show you how it's done. On line number 36, I am using the put method to add a value to the mutable map. We can use the augmented assignment add operator to do the same thing. Let me show you how it's done. On line number 39, I am using the augmented assignment add operator to add an entry to the mutable map. I am using the map of function to create a new map and appending it to the existing mutable map. You can also add multiple entries using this method. Let me show you how. On line number 42, I am using the same method to add multiple entries to the mutable map. You can also use the indexing operator to add a new entry to the map. If the key you use for the entry already exists within the map, the same operation will replace the existing value of that key with the new value that you provide. Let me show you how. On line number 45, I am using the indexing operator to store the value 4 with the key lam in the mutable map. And on line number 48, I am using the same indexing operator to modify the value stored with the key lam. Now, let me run this program so that we can see if the output matches our expectation. The first printed output is from the print statement on line number 34. It is showing the initial entries in our mutable map. In the first operation, we are putting the key pam with the value 4 in our mutable map, and that is exactly what we see in the second output. In the next operation, we are adding entry with the key jam and the value 5 to our mutable map, and that is exactly what we see in the next printed output. In the next operation, we are adding 2 entries to our mutable map. The first entry has the key fam and the value 6. The second entry has the key dam and the value 7. And therefore, our mutable map now contains 2 more entries with the key fam and dam and the values 6 and 7. On line number 45, I am using the indexing operator to add a new entry with the key lam and the value 4. And that is why our printed output now has the key lam along with the value 4 in it. On line number 48, I am using the same indexing operator to modify the value stored with the key lam and storing the value 50 in it. And then once again I am printing the mutable map. And after completing this operation, the value of the key lam is equal to 50. To remove an entry from a mutable map, we can use the remove method. Let me show you how it works. On line number 51, I am calling the remove method on my mutable map and passing it the key jam. On line number 52, I am printing the mutable map after this operation. Let me run this program so that you can see that the entry with the key jam is removed from our mutable map after this operation. As you can see in the printed output, the entry jam is equal to 5 was present within our mutable map, but after we removed it, it is now gone from the mutable map. Moving on, we can iterate over maps just as we iterated over lists and sets using a for loop. Let me show you how it's done. On line number 55, I have created a new map named Iterating map. On line number 57, I am using a for loop to iterate over the iterating map. And within that for loop, I am using the variable k to hold the key for each entry, whereas I am using the variable v to hold the value for each entry. And on line number 58, I am printing the values of k and v for each entry. Let me now run this program so that you can see the printed output. The output looks exactly as we expected it to look. The key and values are printed for each entry. Now, let us do the same thing using the for each method. On line number 61, I am using the for each method to iterate over each entry within the map. And I am using the variables k and v to store the key and value of each entry. And then I am simply printing the key and the value for each entry. Let me run this program so that you can see the output. The output did not change at all because we were trying to perform the same operation using a different method. Before I end this lecture, let me show you how you can use iterators to iterate over a map. On line number 65, I am creating a set which contains all the keys from the iterating map. And then on line number 66, I am simply creating an iterator to that set. On line number 67, I am asking the while loop to continue looping as long as the map iterator has the next value. On line number 68, I am using the next method on my map iterator and saving its value to the variable next key. On line number 69, I have created a variable named next value and I am storing the value stored within next key in that variable. On line number 70, I am printing both the next key and the next value, and this process will take place for each and every entry within the map. So let's run this program and see the output. As expected, the first key is tam and the first value is 1. The second key is sam, the second value is 2. The third key is zam and the third value is 3. Now that we are done covering lists, sets and map, it is time to move towards functions. But that will be covered in the next video. That's all for today's video. As always, feel free to share your valuable thoughts and feedback in the comment section. If you liked the video, smash that like button. If you are new to the channel, consider subscribing and don't forget to hit the bell icon to receive timely updates of all future uploads. I'll see you in the next one.